This is Biology 160, Introduction to Anatomy and Physiology, lectures on the cardiovascular system. We want to take some time today and look at cardiac output, and also we'll take a look at blood pressure as well. Before we get into that though, let's take a minute and review what we talked about in the last section of this lectures on cardiovascular system, and review how blood is going to move through the body. So let's say that you're a drop of blood, or maybe you're a red blood cell traveling around the body, and let's say that you are right now in the right atrium. What I want you to do is follow the pathway of that red blood cell, starting in the right atrium until it comes back into the right atrium. Go ahead and stop this recording, stop this lecture, take a minute, even write down the different places it'll go through, including the valves that red blood cell is going to pass through in order to make one complete circuit around the body. And when you're done, you can turn this back on and we'll review. Okay, welcome back. Let's see how you did. So you're a red blood cell. Right now you're in the right atrium. From the right atrium, the first thing you're going to do is go through the AV valve on the right side. This is also known as the tricuspid valve. From there you're going to move into the right ventricle. From the right ventricle, you're now going to move through a semilunar valve into the pulmonary arteries, which are going to take you to the lungs. In the lungs, you're going to pick up oxygen, and you're now an oxygenated red blood cell. You're going to follow back along the pulmonary veins to the left atrium. Now you're in the left atrium. From the left atrium, you're going to move through the left AV valve, also called the bicuspid valve, into the left ventricle. And then from the left ventricle, you're going to be pumped through the other semilunar valve, up into the aorta, and into the systemic circulation through all the body, to the capillary beds of the body. From there you'll move back into the veins, which will eventually dump back into the vena cava, which are the large veins that are going to dump back into the right atrium, either the superior or inferior vena cava. And then from there you're going to dump back into the right atrium, and you finish one circuit of the body. In order to talk about cardiac output, we need to define a few things. The first one is cardiac output, and that is basically the amount of blood that's pumped by each side of the heart in 1 minute. And this is focusing mainly on the ventricles. Cardiac output is determined by the stroke volume and the heart rate. That's what determines how much blood is being pumped by the ventricles. The stroke volume is simply the amount of blood that the ventricle is pumping. And then the heart rate, of course, is how many beats per minute the heart is going to pump. This usually remains pretty constant. The stroke volume doesn't change very much, and usually in a healthy person is about 70 milliliters, which is about 2 ounces of blood. That's pumped out of the left ventricle with each heartbeat. And that's the same amount that has to be pumped out of the right ventricle as well. And that's something interesting. The cardiac output, the two ventricles have to be the same. If one is pumping out more or less blood than the other, things are going to get, they're going to start to pile up over time. So there's our 70 milliliters of blood per minute in the stroke volume. The heart rate, the 75 beats per minute is kind of an average. Some people have a fast heart rate, some people have a slower, but that's usually about where it is. And so the way we figure out cardiac output is we take the heart rate and we multiply it by the stroke volume. So, for example, someone that has a heart rate of 75 beats per minute and a stroke volume of about 70 milliliters per beat, you multiply those two and it gives you a total of 5,250 milliliters per minute that is being sent around the body. If you remember back to when we talked about blood, we said that Average person has about 6 liters of blood, or about 6,000, that'd be about 6,000 milliliters. And so basically, every minute, all of the blood in your body is being sent around the body once. So that's pretty amazing. So that means that as many minutes as there are in a day, that's how many times the blood in your body is being sent around, because it's cardiac output. Something interesting about the stroke volume is it's determined by something we call Starling's law of the heart. And what this says is that the more you stretch the heart, the stronger the contraction is going to be. And so, in other words, the more volume of blood that's coming back to the heart and filling up that ventricle, the more it's stretching that ventricle, the stronger that contraction is going to be as it's sending it around the body. The heart rate is usually the way that we affect cardiac output, though, because the stroke volume remains pretty constant. Even though as the more that it stretches, the more that it sends around the body, that's going to remain pretty constant. And so the heart rate is the easiest way to change our cardiac output. There's a number of ways to affect the heart rate, and we'll look at that here in just a second. In the stroke volume, there's a few things that can affect the stroke volume as well as we move through and look at how we're going to affect the cardiac output. So let's look at some of the things that can affect cardiac outputs. Here's our cardiac output down at the bottom, and basically what this is a flow chart, so showing all the things, all the factors that can come in to affect the cardiac output. Initially, the cardiac output is a combination of the stroke volume and the heartbeat. And actually, maybe I'll use the same colors here. When I have a green arrow, or when this shows a green arrow, that means an increase, and a red means to reduce. And so the stroke volume and the heart rate come together to affect this cardiac output. If the stroke volume goes up, then the cardiac output will go up. If the heart rate goes up, the cardiac output will go up as well. What this means, though, is that if we want to maintain a certain cardiac output, we can do that by adjusting the heart rate or the stroke volume. So for some reason, the stroke volume changes. Let's say we lose some blood. Then, in order to stay the same on the cardiac output, we can increase the heart rate, and that will bring us back to the same cardiac output. And the same thing. So if the stroke volume increases and we want to keep the same cardiac output, we can decrease the heart rate, and etc., etc. So you can see how these two work together to help adjust and maintain this cardiac output. So some of the things that affect, let's first of all look at the heart rate. So what are some things that affect our heart rate? First of all, one of the big things is your age. So simply your age, your gender, how much you exercise, your body temperature, all of those things can affect your heart rate. So in general, older people are going to have a slower heart rate. Your highest heart rate is most likely going to be when you're a fetus, and it can be well over 100, 140, 150 beats per minute, and that's fine. And then over time, it's going to decrease as you get older. Usually males have a slightly slower heartbeat than females. So females on average 72 to 80 beats per minute. Males are going to be a little less at 64 to 72 on average. And so your gender as well is going to affect that heart rate. Heat always increases your heart rate. A good example of this is when you have a fever. You'll often experience what would feel like a pounding heart rate. Your heart rate's going really fast, and that's simply because your body's heating up, and so the metabolism is increasing. That's going to affect your heart rate as it goes on. There's also stresses in your environment that can increase your heart rate as well. Okay, one of these can be temperature. Another can be exercise. So as you exercise, your cells are actively working, your muscle cells, they're demanding more oxygen, and as that demand increases, your body has to provide that oxygen. The way it does that is by the blood. And so as you experience stressors, exercise, this can be this is kind of the flight-fight type idea here. So if you get scared, you get excited, you're exercising, all those things are going to cause your sympathetic nervous system to activate. And what that's going to do is it's going to trigger your body to increase your heart rate. And as that heart rate increases, that's going to affect your cardiac output. It's going to increase cardiac output. After that crisis is passed, your parasympathetic system is going to come into play here. And as your parasympathetic system comes in, that's the rest digest system. And so your parasympathetic system is going to say, okay, we're done exercising, let's lower that heart rate, we'll get back to where we are. So these two work in, they're antagonists of each other. The sympathetic system is going to increase your heart rate. The parasympathetic system is going to decrease that heart rate. So they work together in that way. There are also hormones that can affect your heart rate. So things like epinephrine, which is one of the main hormones of the sympathetic nervous system. Thyroxine is another hormone that is produced and is used to increase the heart rate that you have. So all these things come into affect the heart rate. Some other things to look at: low blood pressure. So low blood pressure. If you have low blood pressure, that can also activate and cause your heart rate to rise. High blood pressure or a lot of blood volume can cause your heart rate to decrease as well. And then some of these things are going to affect the stroke volume as well. So here's our stroke volume over here. Notice that the sympathetic system also can affect your stroke volume as well as the hormones. And what happens here is this is going to increase the contractile force of the cardiac muscles, which increases the stroke volume. That's going to increase your cardiac output. One of the main things that can affect your stroke volume is the venous return. So what this means is you have more blood coming back to the heart, and what that's going to do is it's going to stretch the muscles of the heart, the myocardium, and that's going to increase your stroke volume because the heart's going to pump stronger. Some things that can do this: exercise. As your heart is pumping, as it starts to pump faster, that's going to cause more blood to come back to the heart, and so it's going to increase the stroke volume of the heart. On the opposite side, if you decrease the blood volume, so let's say you get cut or there's a hemorrhage or you're losing blood somehow, that's going to decrease the amount of blood that's coming back to your heart, and that's going to decrease the stroke volume. As that happens, the heart rate has to increase to make up. So if the stroke volume starts to decrease, the heart rate has to increase in order to keep that cardiac output the same. So if you're losing a lot of blood, your heart rate's going to increase. If that increases for a lengthy period of time, your heart can eventually fatigue and it can lead to a cardiac arrest. And so losing blood can be a very dangerous thing. So all these things are coming together to affect this cardiac output. How much your body is, your heart is pumping, how much blood is moving around the body, and these things are working together to keep that stroke volume where it needs to be.